Good morning, everyone, and this is lecture number 6, and we were on motion in 1D. Now, the last class we had was like some 8 or 9 days back. Do we remember what we had discussed in the last class? Do you recollect what we had discussed in the last class, or have we forgotten everything that we had done? Hmm? Do you remember, or is gone out of the system? No one remembers it?
Types of velocities.
We were dealing with velocity, and we had seen that velocity is the rate of change of position with time. We had seen different types of velocity: uniform velocity, a particle moving with the same speed in the same direction. Then we had a non-uniform velocity, where the magnitude or the direction or both of the velocity changes. We had seen that. Yes or no? We remember this? Velocity keeping on changing. It may keep on changing in magnitude. It can keep on changing in direction, or it can change in both. Then we have seen average velocity, total displacement divided by total time. We remember this? Yes or no? Then we had seen your instantaneous velocity, and we had seen the relation between instantaneous speed and instantaneous velocity. Do we remember this? Many a times students are confused between speed and velocity. Remember, speed and velocity are totally different terms. There is no relation between speed and velocity. The only thing you can say that has a definite connection is instantaneous speed and instantaneous velocity. Instantaneous speed is the magnitude of instantaneous velocity. That is the only relation that we have. Do you understand this? Yes or no? What we will do is, just to refresh ourselves, we will write some important points about or differences or comparison between. Let us first start with average speed and average velocity. So that is the first heading that we are going to write for the day: comparison between average speed and average velocity. Average speed, and I have written speed as S, and average velocity. Remember, there is no relation between average speed and average velocity, but you can always compare them. The first thing that must always come to your mind is average speed is which type of quantity? Average speed is which type of quantity? Scalar or vector?
Scalar quantities.
It is a scalar quantity, and average velocity is a vector quantity. Yes or no? Remember, there is no relation between a scalar and a vector because they are totally different things. Yes or no? Then we must remember that average speed is total distance L divided by total time, whereas average velocity is total displacement divided by total time. Do we remember this? Yes or no? We all remember this? Now, now, one thing that you must understand, that is similarity between this average speed and average velocity are always calculated over a time interval. Always calculated over a time interval. So we do not have any instantaneous value of average velocity. Whenever we talk about average speed or average velocity, we are talking about average speed or average velocity between 2 points. Do we understand this? It is always average speed or average velocity between 2 points. I don't see any one of you writing anything, and that's a dangerous sign. It's a very dangerous sign, right? Everything that I utter for you, I am like a God sent messenger. Whatever I am saying is going to come in your exam. And once you see it on the whiteboard, you might think that you know it. But what happens is when we require it, you might not recollect it. So you'll have to write everything that I say. May not be in the same language, in the language that you understand. You may understand sign language, you may understand it by making it more beautiful, highlighting it with yellow, blue, green, whatever, writing it in your own language, whether it is Telugu, Tamil, Hindi, Tamil, Malayalam, doesn't matter. You'll have to write them and you got to remember them. Okay, average speed and average velocity both are calculated over a time interval. For a given time interval or for a given interval, whether it is in time or it is in terms of distance, average velocity will always be a single value, will always be a single uh, valued vector, whereas your average speed can have different values. Why is that so? If I am going from point A to point B, my average velocity will always be same if the time is same, but my average speed can be different. Why it can be different? Because average speed depends on what? Average speed depends on path, but average velocity is simply total displacement divided by total time. So if the time is same, average velocity will always be same. Do we understand this? Okay. Average speed is always positive because distance traveled by a particle is always positive. Whereas if you talk about average velocity, it can be taken as positive or negative, which positive or negative for this average velocity always refers to its direction. Do we remember this? Remember, the magnitude of a vector is always positive. Whenever we say a vector is positive or negative, we are referring to its direction. I hope you remember all these things, yes or no? Then one more thing, if the particle comes back to its initial position, if the particle comes back to its initial position, what you can say about average speed and average velocity? Average velocity will be greater than 0, but what about average speed would be greater than 0, but what we can say about average velocity? It will be equal to what? The particle comes back to its initial position. Average speed will not be 0, it will be greater than 0. What about average velocity? What can you say about average velocity? Yes?
Equal to zeros.
Why, sir? Why it will be 0? Because total displacement will be 0. Do we understand this? Everyone understands this? Yes or no? Okay, I hope you have all noted this down. Yes or no? I'll give you 1 minute to note it down, then I will present a question. And that is taken from, I think, your sheet only. And If you have written, then I will move on to the question. Have you written it, bacha? Everyone has written this? Shall we move on to the question? Now, shall we move on to the question? Yes or no?
Yes, sir.
Here is the question. A particle moves along the side AB, goes from A to B, then from B to C, then from C to D with a velocity. It should not be velocity because velocity is not uniform here. Sometimes you get this with a speed of 15 meter per second. So it moves like this, 15 meter per second, done. The side of the square is 5 meter with a speed of 15 meter per second. What is the average velocity? How will you find out the average velocity? Okay, let us break this question into small things. Instead of straight away finding the average velocity, can you first tell me what will be the average speed? What would be the average speed? Now remember here, he is moving with a constant speed. Do we understand this, that he is moving with a constant speed? Yes or no? Do we understand that he is moving with a constant speed? If it moves with a constant speed, your average speed, your instantaneous speed, all are same. Do we understand this? Yes or no? So what will be the average speed? Can I have that answer? What will be the average speed of the particle? What will be the average speed of the particle?
15 meters per second.
Everyone understands this? Please raise your hands and tell me that we understand this. Average speed. Now, you have to tell me average velocity. Now, whatever is written, whatever options are there in the question, whether it is option number A or B or C or D, all these options are only giving me the magnitude of average velocity. What will be the direction of average velocity? Can anyone tell me? Because that is also important. What will be the direction of average velocity? Remember, average velocity, velocity, instantaneous velocity, uniform velocity, whatever. Velocity always has a direction. In this case, what is the direction of average velocity? Yes. What will be the direction of average velocity? Who is going to tell me? All these simple things make a lot of difference. What is the direction of average velocity? Anyone? What is the direction of average velocity? No one knows it? No one knows it, beta?
Positive or negative, sir?
I am not very impressed. Negative, positive. It all depends on how you are taking positive and negative. I can't read your mind, bacha. I don't know what is positive and what is negative unless and until you tell me. Again, try. What is the direction of average velocity? Remember, there is no right answer and no wrong answers. Right and wrong are just in our heads. Yes. What is the direction of average velocity? Anyone would like to try? Well, it seems like you are still in the festive mode and no one has revised anything that we did in the previous class. Remember, beta, this is physics. And it is as easy as it gets and it is as tough as you make it. If you come to the class, any class, before any class without studying what we had done in the previous class, this class is going to be a waste. Then the next class is going to be a waste. Then the next class after that is going to be a waste. And slowly, your entire physics is going to be a waste. Do we understand this? Do we understand this? That if you come to the class without going through what we've done in the previous class, your entire physics is going to be a waste because this is not chemistry. This is probably also not maths. In physics, every topic, in fact, every class, forget about topic, every class is related to the previous class. It's not like chemistry when you are done with ionic equilibrium and you move on to inorganic chemistry and you are doing hydrogen. Forget about ionic equilibrium. You know nothing. Even if you know nothing about ionic equilibrium, the next topic, oh, hydrogen, you can still understand hydrogen. You understand nothing about hydrogen. The third topic is nomenclature of organic compounds, and you are again making jolly. That is the liberty chemistry has. Physics does not have that. So, if you don't study before coming to the class, it will not be productive. Right now, what I'm telling you is from the previous class that we did. Can anyone read what I wanted you to point? What I wanted to point to you? I asked in the question, what is the direction of average velocity? Do you see anything? And I have not made this up because this was already given to you in the previous class. If I have to repeat the same thing 10 times, that means I will only be able to cover 1/10 of the course. Sad. Okay. Yes, what I wanted to sell, what I wanted to not sell, what I wanted to tell is there on your screen right now. Can anyone read this for me? Wake up. Can anyone read this? What I wanted to point out. This is from your previous class. I gave you a question. I asked you the direction of average velocity. And then I showed you this screen. What is there in this screen? That might tell you what is the direction of average velocity. Read it, read it, read it, read it. Read it loud.
Same as change in displacements.
Displacement does not change, my dear friend. It is delta r vector is displacement. If you have forgotten the symbol of displacement, everything I have done till now has been flushed down the dirtiest toilet in the entire city of Hyderabad or in the entire country of India. Dirtiest drain, it has been flushed and thrown out. Delta R vector is not change in displacement. I never uttered the word change in displacement. Delta stands for change. R stands for position vector. Delta R stands for change in position vector, which, my dear friends, please recollect, is equal to your displacement. Is it clear now to everyone? Please never use change in displacement for displacement because it kills displacement. And if displacement is killed, you have killed the basic of physics in mechanics. Everything gets killed. It's like if you kill the grandfather, before he becomes a father, the entire generation is killed. Grandfather paradox it is known as, and that is what prevents time travel into the past. Do we understand this? The direction of average velocity is same as the direction of displacement. Do we understand this? Yes or no? This is a yes, this is a no. This is like, oh, we don't worry. Everyone understands this? I still don't see raise hands from everyone. Okay, come back to the question once again. And the question still remains. Forget about what the question was. The question still remains. What is the direction of average velocity? Yes. Try again. Because if we don't understand the basic concept of direction and velocity, my just solving the question will not serve any purpose. Yes. Tell me what is the direction of average velocity. First. How has the particle moved? From where to where? From where to where has the particle moved? Yes, bacha. No one knows from where to where the particle has moved. Can someone read the question for me? Question. I hope everyone can see the question. Can anyone read the question from me? We are not going any further without solving this question. So if you keep shut, I'll keep babbling and we'll still remain on this screen for the entire class. Yes. Can anyone read the question for me? Because I want you to understand. Because I want to understand whether you have understood the question or not. Yes.
A particle moves along the side AB, BC, CD of a square of side 25 meters with a speed of 15 meters seconds.
15 meter per second. Yes.
Its average velocity is.
Okay. So do you understand from where to where the particle has moved, beta? Yes. From where to where? Speak up. From where to where has the particle moved?
From A to B, B to C, C to D.
So what is A? A is known as its initial position. Yes or no? Yes or no? Do we understand this? Then what about D?
Yes, sir.
D is?
Final position.
Now, I again repeat my question. What is the direction of average velocity? A is the initial position. D is the
5
final.
meters.
I've asked you, bacha, the direction. I am not worried about the magnitude of velocity. I'm asking you again, what is the direction of average velocity? The direction of average velocity. Anyone can tell me what is the direction of average velocity? It is same as the direction of displacement. And what is the direction of displacement? Can you tell me what is the direction of displacement?
A to D.
Well done. Now we are back in business. This is the direction of displacement, the green arrow. Green arrow is a very famous Marvel character. Green arrow. Green arrow comes here. The green arrow is the direction of displacement, and therefore this green arrow is also the direction of this green arrow is the direction of displacement. This green arrow is also the direction of average velocity. Do we understand this? Yes or no? Chalo. So we know the direction of average velocity. We have to find the magnitude. How do you find the magnitude? I will not write it as vectors because I have already told you its direction. I will just write it as a scalar. What is the direction of average velocity from A to D? What is the magnitude of average velocity? How do you get the magnitude of average
5
velocity?
meters.
Yes, beta?
25 meters.
Beta, that is meters. It cannot be average velocity because velocity ka dimension or velocity ka unit is meter per second. Yes or no? What is 25 meters that you told me? What is this 25 meters? Is this average velocity or is it something else? Yes, tell me. 25 meters, what is this that you told me? It is definitely not average velocity because it is meters. So what is this then?
Displacement.
Well done. This is displacement. Total displacement divided by total time. So you have forgotten to divide it by time. Dashera has taken a heavy toll on us, and I wish this Dashera would never have come. And if Dasheras are like this, then you don't deserve any Dashera in your life because Dashera is dangerous, harmful. It has ruined the entire physics that we have studied. Anyways, I hope better things will come. 25. Can anyone tell me how will I find the time? Because I don't know time here. How will I find out time? That is the only question that we must understand here. How will I find out time? Now, to find out time, I will help you out. It is given that it is moving with a speed of 15 meter per second. It moves with a speed of 15 meter per second. So, if I understand that to move from here to here, the distance it has traveled is 25 meters, yes or no? From here to here, it has again traveled 25 meters. From here to here, it has again traveled 25 meters. What is the total distance it has traveled? The total distance it has traveled is 25 plus
25
25,
meters.
75 meters. Well done, my dear friend. And its average speed is 15 meters per second. Do we understand this?
Yes, sir.
From here, I can find out how much time he has taken. How much time he has taken to go from A to D. The time in this case was not given straight away. It was given in an indirect way. I know that he has traveled a total distance of 75 meters and his average speed, uniform speed, was 15 meters per second. Can you now tell me, Bacha, how much time he has taken to travel 75 meters with a speed of 15 meters per second? I hope that you can tell me this. Yes. His speed is 15 meters per second. His
2
distance,
seconds.
how much, Bacha?
5 seconds.
5 seconds. That is correct. How did you get 5 seconds? Total distance divided by the average speed. Yes or no? So 75 divided by 15. That will give me 5 seconds. As soon as I get the time, which was the only thing that we had to find out here, apart from the displacement was already there on the whiteboard. Now, you can tell me what is the magnitude of velocity, average velocity. What is the magnitude of average velocity? Yes, what is your answer now?
5 meters per second.
25 divided by 5 is 5 meters per second. And what is the direction, my dear friends? So I also write the direction. What is the direction? What is the direction? From A to D, which in the figure is looking like this. Do we understand this? Was it so difficult that you could not do it on your own? Do you think that you could have done this on your own? Yes or no? Everyone thinks that they could have done on their own. I want to raise hands from everyone. If anyone has a doubt, please raise. I understand that you have come back and you are still not in the mood. Probably you have forgotten some things, and I can understand that. That is human nature that we can forget if we don't revise. That's human nature, and I understand that. But okay, first class, so I'll take it. Do we understand it now? Yes or no? Raise hands from everyone.
Yes, sir.
Okay. Remember the definitions. If you even think that you don't recollect it, you can just go back and read the notes that you have made. Only 5 minutes of your precious time it will take, and you will be back with a bang. You will be able to solve problems. Can I move on to the next question? Everyone is ready? Everyone thinks that they can do it now? Yes or no? Then let's go for it. So now what I am going to do is I am going to create this. What is this? My drawing may not be very perfect, but I hope you understand what I have drawn. What I have drawn here? What is this figure?
Semicircle.
This is a semicircle, and the radius of this semicircle is, let us say, 5 meters. A particle moves from A like this to B. A to B, a particle moves. The time it takes is 10 seconds. A particle moves from A to B along a semicircle. The radius of the semicircle is 5 meters and the time it takes is 10 seconds. Now I have a couple of questions. Find out number one, and I will write it in symbols. L delta R. I'm not writing the vector sign because I will ask you the direction orally. L delta R, dabba S, and dabba V. Do we understand the meaning of these symbols? What is L?
Distance, displacement,
Third
average
one.
speed.
Fourth one. Fourth one.
Average velocity.
Well, you have 2 minutes to solve this question and get back to me and throw the answers on my face. Sir, take it. Take it. We have solved it. When I wait for your throwing back answers, and I will try to catch them. I may not be able to catch all, but probably I'll catch one of these. 1 minute, I'll wait. Well done. I can see all of you trying the question. That is a good sign. Well done. Answers don't matter. Right answers, wrong answers don't matter. What matters is that you try them sincerely. Because if you try, you are going to succeed no matter what happens. I'll wait for 1 more minute. I see everyone trying. Good. Well done. Yes, my dear friends. Are we there with answers? Throw them, throw them, throw them, throw them. Let us think about the first one. What is the total distance traveled? Yes. Are throw? Yeah, I have got nothing to throw. Are throw something. Throw the first answer. What is the distance traveled? Yes. No one knows it?
15.7, sir. 15.7 meters.
Oh, that's a very precise answer. How did you get it? How did you get it? So basically, to find out the distance, what you need to calculate? Tell me. What I need to calculate to find out the distance travel? I need to calculate what?
Circumference of a semicircle.
Yes, I need to calculate the length of this path. So basically, I need to calculate the length of this arc, which is a semicircle, and the length of this arc will be equal to pi multiplied by r. Yes or no? That is the answer. So pi is pi, r is 5. So I can just simply write it as 5 pi meters. Do we understand this, everyone? That is the length of the path, and that is equal to the distance traveled. Now coming on to displacement delta r. First tell me the direction of displacement.
A to B, sir.
From A to B, and I draw it with this pink Hulk, lady Hulk, pink Hulk. Hulk? No, green arrow, pink arrow, pink arrow. That is the direction of displacement. What is the magnitude of displacement? Tell me now.
10 meters, sir.
It is 10 meters. And to draw the direction, I will just draw this pink arrow. That is the direction. Okay. Now let us move on to the third quantity, and that third quantity is average speed. What is average speed?
5 pi by 10, sir.
Total distance divided by total time. Total distance is 5 pi, and if you look closely, total time t is already given to you as 10 seconds. So I will just divide it by 10, and I will have pi by 2 meter per second as my average speed. Do we understand this, everyone? Raise hands will give me more confidence. Boys of Chintal Center don't understand, I think. Do we understand this? Okay. Last but not the least, I have to, oops, why I have written delta? Last but not the least, I have to know what is average velocity. But before going into average velocity, what is the direction of average velocity? What is the direction of average velocity? Yes.
A to B, sir.
From A to B, so it would be like this. Now tell me the magnitude. It is total displacement divided by total time. Yes, it's 10 divided by 10. It becomes 1 meter per second with the direction from A to B. Do we understand this, everyone? Remember, there is no relation. As you can see, beta, here you look at average speed, you look at average velocity, they are totally different. They are calculated in totally different ways. Therefore, there is no relation as such between average speed and average velocity. Can we move on ahead in life? Okay, this was average speed and average velocity. Let us now try to compare the other two quantities which definitely have some relation. So let us now compare instantaneous speed, which I write it as S, and instantaneous velocity, which we write is as V vector. Now, first thing first, instantaneous speed S, what type of quantity is instantaneous speed? It is a scalar quantity. What type of quantity is instantaneous velocity? It is a vector quantity. Do we understand this? Yes or no? Now, there is a relation between instantaneous speed and instantaneous velocity. Instantaneous speed can be written as is the magnitude of instantaneous velocity. Do we understand this? Yes or no? So I can write this S as velocity V ka magnitude, and velocity V ka magnitude is simply written as V. So I can also use this V for instantaneous speed. But wherever I am going to use V in the equation that we are going to make, this V is going to mean velocity only, and therefore I have used the term S for speed. Do we understand this? So that you don't get confused between speed and velocity, V I will always use for velocity and S I will always use for speed. Because of the same term being used for speed and velocity, students get confused between speed and velocity. So I will only use V for velocity and S for speed. Am I clear with this? Okay, now sometimes the particle is not going to move on a straight path. How do I find the direction of instantaneous velocity? Now remember, and I'll show this with a diagram. This is going to come in the next chapter. This type of motion is going to come in the next chapter, which is known as projectile motion. Have you heard about the term projectile motion? Anyone? Have you heard about the term projectile motion? Yes, so this type of diagram is going to come in projectile motion, but let us also see it now. And what I want to bring here is the direction of instantaneous velocity. Now, what do you see here is a particle moving like this along this path. Do you see how the particle is moving? This particle is not moving in a straight line, but he is moving along the curved path. Do everyone see this? Now, at different points in that curved path, I have drawn different velocities that the particle has. For example, in the beginning, the velocity is v1, then the velocity becomes v2, then v3, then v4, and so on. Now, I have also drawn, if you can look closely, the green arrows, and these green arrows actually represent the direction of instantaneous velocity. Do we understand this? These green arrows represent the direction of instantaneous velocity, and from here I can write the direction of instantaneous velocity I've also seen the direction of average velocity. It is same as displacement. The direction of instantaneous velocity is always tangential to the path. So no matter how the body is moving, the direction of tangential velocity is the direction of velocity, instantaneous velocity is always tangential to the path. Do we see this? This is example number 1. If I give you one more example, the same example that I gave you in the question, the particle was moving in a circular path. At this point, if I draw its velocity, it will be tangential. At this point, if I draw its velocity, it would be tangential. At this point, if I draw its instantaneous velocity, remember, not average velocity. At this point, if I draw it, it is tangential. At this point, if I draw, this is also tangential. Do we understand this? That the direction of your velocity is always tangential. The direction of velocity is always tangential. And the magnitude of instantaneous velocity is instantaneous speed. Everyone understands this? Direction is important with velocity beta, because if you miss the direction, then you miss the most important aspect of velocity, that is the direction. Now, remember, instantaneous velocity or instantaneous speed, they're always calculated at any instant, because the name says that they are instantaneous. They are calculated at any instant. Do we understand this? Average velocity and average speed are calculated over an interval of time, but instantaneous speed and instantaneous velocity are calculated at a particular time. Very important difference between the two. Do we understand this? Fifth point, if a particle is moving with uniform speed, if a particle is moving with uniform speed, S will be equal to S dabba. Do we understand the meaning of S and S dabba? S means instantaneous speed, S dabba means instantaneous average speed. If a particle moves with uniform speed, both are same. Do we understand this? Then there will be one more statement. Instead of speed, I will use what in the next statement? Instead of speed, I will use
Velocity, sir.
well done. And instead of instantaneous speed, I will use instantaneous velocity. For a particle moving with uniform velocity, if a particle moves with uniform velocity, the instantaneous velocity will become equal to average velocity. Do we understand this? Boys in the class, I don't see any. Everyone has their. You come here after a bath and breakfast, no? Yes or no? Or you come just like me. You get up, you wash your face, and you come out. Okay, let's sit there. I hope you have a healthy breakfast. I mean, as kids, you are kids only. As kids, you must get up. The latest that you get up is 6 o'clock. That is the latest. Now, how many of you get up before 6 o'clock or by 6 o'clock? Anyone? So many? Okay. Then you must be having a sorry. I take my words back. Then I am the one who's the culprit. You must have had your breakfast. You must have had your bath. I'm sorry. I take it back. And I move on to the next question. What was I forgotten? I told you, I thought that I'll give you a big good lecture on getting up early, but everyone gets up early. I forgot. Where was I? Okay, we are doing uniform velocity and uniform speed. And I hope you have understood the concept. Anyone has noted this down? Then I will bring some questions from the sheet. You got the sheet that I sent you, yes or no? So this is the question from the sheet only. And I think this is, if you have the sheet, you can look at the sheet. This is question number 14, I think, from the sheet. Question number 14 from the sheet, and I will call it question number 14 only, so that it reminds you. These are the type of questions that you can attempt first. When a particle moves with uniform velocity, which of the following relations are correct? Don't have to write the entire question.
Sir, we
Look
have
at
not yet written.
what you have not written.
Previous one.
Sad. I gave you so much time. Okay. Take more time. Time is a luxury that we don't have, my dear friends. So spend your time wisely. Right? While I have given you the time. And write things. See, try to understand. You don't have to copy everything from the whiteboard. My language is what I understand. It may not be the language in which you understand. You don't have to write everything in English. English is not a mother tongue. You don't have to write everything in that. Write in your own way. I have seen some very nice notes of students. I have them, but I can't show it to you because I don't know where they are kept. Everything is so, I used to explain it in English or Hindi or Malayalam or Tamil. I don't know Malayalam, Tamil, Telugu. But students used to write it in their own way, highlight things in their own way, write it in Hindi, write it in this, write it in that, write it in Marathi. And the notes were very good because it made the student understand what I had taught in the class. Don't just go by English, just write everything, babbling in English, writing everything on the board, write it
Sir, completed.
in such a way that you understand it. That brings me to the question. And the question is straight away here. Don't have to write the question. Don't waste your time in writing the question. It is there in your sheet. Look at your sheet. Question number 14. Tell me the answer. When a particle moves with uniform velocity, which of the following relations are correct? Remember, whenever you see average speed and average velocity getting equated, they are equating the magnitudes, because speed is scalar, velocity is vector. They cannot equate scalar and vector. They are equating the magnitude. Which is the correct answer? Here they should have written magnitude of average velocity. Yes. Which options are correct? Yes, my dear friends. Option number 1, average speed is average velocity. Will it average speed is magnitude of average velocity. The particle is moving with a uniform velocity. Is the first option correct? Yes or no?
No, sir.
This is a yes, this is a no. No, sir. You don't think it is correct? Why it is not correct? If he moves with uniform velocity, he is moving with uniform speed in the same direction. He never changes his direction. He never changes his direction. His average speed will be equal to the magnitude of average velocity because he's always moving in the same direction. Do we understand this? Option number 2, instantaneous speed is equal to magnitude of, they have again not written magnitude. Instantaneous speed is the magnitude of instantaneous is equal to the magnitude of instantaneous velocity. Yes or no? Yes? No.
Sir.
Yes, it is always correct. Yes or no? Do we understand this?
Yes, sir.
Option number 3. Distance traveled is equal to the magnitude of displacement. In the third part, they have written it correctly. Is this correct or not? Yes or no?
Yes, sir.
Yes, sir. Then what is the answer, sir? A, B, C, D. Which is the correct answer, sir? A.
A.
A is the correct answer. I hope everyone has understood this. Yes or no? No, yes. Can I have raised hands from everyone that we have understood this?
Yes, sir.
Well done, sir. Then one more, sir, for you, sir. And remember, sir, every question has the potential of coming in your JEE, whether it may be JEE Main, it may be JEE Advanced. Again, this question is taken from your sheet. Don't have to write it. Don't waste your time in writing it. Time is a luxury that we don't have. This is the question. Something has changed. When a particle moves with variable velocity, tung, 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 which of the following statements are not correct? Now, this is how they confuse you. Sometimes they ask you which is correct. That is an affirmative question. Sometimes they ask you what is not correct. That is a negative or a non-affirmative question. Not correct gives us trouble at times. But let us see if we get caught or if we are able to solve this. Which options are not correct? I mean, whatever it means. Which is the correct option from A, B, C, D? But that correct option should have not correct options. I hope you understand this. Yes or no? Okay, let us discuss option number 1. Option number 1, average speed is equal to, again, magnitude is missing. Average speed is equal to magnitude of average velocity. Correct or not correct?
Not correct, sir.
Well done, sir. See, if you understand things will look easier. Average velocity, it is moving with variable velocity, so it might move in a curved path. It moves in a curved path, distance and displacement. Okay. Option number 1 is not correct. We all understand this. Yes or no? This is a thumbs. This is no. This is we are floating here and there. What about option number 2? Correct or not correct?
Yes, sir. Correct. It's correct.
It is always correct because this is how instantaneous velocity, the magnitude of instantaneous velocity is always equal to speed. Comes the pink arrow. The pink arrow now becomes a pink tick. Let us move on to the third one, green arrow. Distance covered is equal to magnitude of displacement. Correct or not correct?
Not correct.
Not correct. So 1 and 3 are not correct. 2 is correct, but which is the correct option from A, B, C, and D? E. So this is how you must be careful choosing the not correct, but then giving the correct answer. Don't get confused with the language of the question. Please be careful. We have done a lot of hard work, you and me, to bring you up till this stage. And I hope that when you come to the class, in the next class, we will go through at least the last 3 classes so that we can move ahead in life. Do you promise me that you will come with? It will just take 10 minutes of your precious time if you just go through the last 2 or 3 classes. Can you do that for me? Yes or no? Yes, I can see a lot of raised hands. So please revise what you have done in the previous class. In the next class, the last thing that we saw was variable velocity. Why does velocity change? Who changes velocity? What causes the velocity to change? And here comes the next character in the story. Acceleration will now come in the next episode. So I'll see you. Take care. May God bless you all.
Thank you, sir.
Bye bye. God bless you all.